At the end of 2025, Everyday Metallurgy ambassadors got an invitation from UHT in Sweden, a company working with steel reforming and metallurgy. They invited us for a forging crash course. Being metallurgist, mainly with our heads, and not so much with our hands, was a challenge, but it was accepted, and four of us went to a crash course with a local super guy, Peter Knus, who was our teacher during an entire day in the forge. When we entered the forge, we were a bit amazed because it was dark, and it was the old-fashioned way of doing it. The forge themselves were based on coal. We had to fire up ourselves, and there were two different kinds of coal. One that did not reach such a high temperature, and a clean one that was a bit more expensive, that had a much cleaner burn and hence also a higher temperature. Peter wanted us to mainly use the cheap one, but when we had to go to high temperature, we took the other one. When you forge, it is important that you look at what happens in the flame. When you put your steel into the fire, into the coal, you can see it starts to heat up. But when is it hot enough? And we were told when you start to see stars coming out, then your steel starts to burn, and then it's time to take it out. If you do not take it out in time, it will burn and it will disappear. Maybe there are some shots where an ambassador of Everyday Metallurgy was taking in losing the product. The steel we got for forging was spring steel from a Toyota. So pieces about this size were cut out and welded to a stick. Why spring steel? Spring steel is very good when you want to make knife, because spring steel is hardenable. So after forging it, you can harden it to a very high surface hardening, and that is good for knives. We started with this small piece of spring steel, heated it up, and then went to the anvil with the hammer, and were told and taught how to hold the hammer, how to use your body, how to put power into it. It was so easy when seeing Peter doing it, because he could just within 5-10 knocks with the hammer deform the steel, and you could see a blade appeared. But when we did it ourselves, after 10 bangs with the hammer, almost nothing happened. So the power you put in, the position of your body, the experience of doing it is very important. Before we went to the forging crash course, I made a trial. I wanted to make some special Damascus steel. I made a small episode, a short, how to cheat in making Damascus steel on the YouTube channel, where I showed that I could put powder, metal powder, very coarse powder, size about 1 to 1.5 millimeter of the particles. I mixed two different grades. I mixed plain steel, hardenable carbon steel, with a hardenable stainless steel. Because when that was mixed, I would be sure that it could give a very interesting pattern when etching it afterwards. And I made a microstructure analysis of it, how it looked just after I made it, because I made it with HIP. So these two powders, they were mixed and added into a tube. The tube was then welded after evacuating it for air, and then it was placed into a hot isostatic press. And the result, when I look at it in microstructure, maybe you could see here the pattern of it. You can see that the white area is the stainless steel, where the black spots is the normal carbon steel. But this pattern is not really nice. It still has to be forged. So Peter offered to use his automatic forging machine, an air hammer. So the block of steel I had made were hammered on the air forge. It was a lot easier. It was forged, then it was bent, it was forged again, and it was bent, and I think it was bent and collapsed 5 to 6 times to ensure that we got elongation of the pattern. And how does it look then after doing that? I tried to make a knife of it. I never finished because we only had a few hours in one day of doing it. And with the experience I had and my weak arms, it was obvious that I did not have the power to finish that in a day. But here we can see a picture of how it looks. But afterwards, Peter also had a piece of it, and he offered that he would make some special for me out of that steel. And on this picture, you can see that he made a small disc and he made a ring. And if you look closer on the ring, you can see the pattern of the Damascus steel. It's not real Damascus, but it has this pattern where you can see the differentiation between the stainless and the carbon steel in it. I really like it. I think it's beautiful, and I will finish the knife that I started doing, and maybe if I succeed, I'll share a picture of it on the podcast or on the LinkedIn channel, Everyday Metallurgy.
Hi everyone, my name is Amir. I recently joined the blacksmithing course together with the team of Everyday Metallurgy. As metallurgists, we often talk about steel in theory, phase diagrams, heating treatment, and microstructure. But this course reminded me to where metallurgy really started in forge with heat, hammer, and experience. During the course, we learned the basic steps of forging a knife. We heated the steel and shaped it with a hammer and tried to control the temperature while working. Uh, One thing I learned very quickly is that forging looks easy when you watch an experienced blacksmith, but it's much harder when you try it yourself. Uh, in my case, my blade actually cracked before I finished it, but of course that also good reminder that steel very sensitive to temperature and deformation. For me, it was this was the most interesting part of the experience. Um, I can't, in the theory we know as metallurgists with the real behavior of steel in practice. Overall, it was a great experience, and it gave me a lot of respect for traditional blacksmithing and the bladesmith. Thank you.
After finishing the crash course in forging, the team went to have a beer and a rest and take a look at the faces of these guys. You can easily see that they have been in the blacksmith workshop today. So thank you for following. We really enjoyed doing it, and we hope that you'll give us some feedback. You don't need to mention the thin arms and the wrong way of hammering. We are aware that we are not mainly metallurgists in our minds and not with our hands, but we will practice. And hopefully, one day we will learn also to control the blacksmith part of the metallurgy world. Thank you for joining in.